Welcome, my dear students, to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 3, Normal Distribution, brought to you by Vitan Sir. Previously, we completed illustrations 1 to 3, and in this tutorial, I am going to move forward with the next illustrations. We will start with illustration 4. The average weight of grown-up children living in a large society is 50 kg and its standard deviation is 5 kg. If their weight follows the normal distribution and a child is selected at random, then find the probability that number 1, his weight is between 55 and 65 kg, number 2, his weight is between 35 and 45 kg. Okay, here the mu value is 50 kg and sigma value is 5 kg, and we will convert the values of x into z. The first question here, that the x has value between 55 and 65, that is p will be between 55 less than x less than equal to 65. So we will be converting this x into z, which is x minus mu upon sigma. So probability 55 less than equal to x less than equal to 65 will be probability 55 minus 50 upon 5 less than equal to z less than equal to 65 minus 50 upon 5. Now when we solve these two values, we get 1 less than equal to z less than equal to 3. Now that means our data, the value is between 1 and 3. So when we draw the curve for this value, the normal curve, it will be between 1 and 3. So the highlighted part is between 1 and 3. Now just looking at the curve, we know that we need to calculate probability between 1 and 3. So we will be calculating it as 0 to 3 and the difference between 0 to 3 and 0 to 1. So 0 less than equal to z less than equal to 3 minus 0 less than equal to z less than equal to 1. Now we know the probability of 3 can be found from the z column 3.0 at the very bottom of the screen. You can find it here, and because it is just 3, we will check it out in the 0.00 column, so it will be 4987, and 1 will be 1.0 in the 00 column, that will be 3413. So it will be 0.4987 minus 0.3413. The answer will be 0.1574. So the probability that the child selected at random will have his weight between 55 and 65 kg is 0.1574. Number 2, x has value between 35 and 45 kg, that is probability 35 less than equal to x less than equal to 45. We will be converting that into the z value, that would be 35 minus 50 upon 5 and 45 minus 50 upon 5. So when we solve this, we get negative 3 and negative 1. So z will be between negative 3 and negative 1. So we will draw the normal curve here, and negative 3 will be on the left hand side and negative 1 will also be on the left hand side, but 3 will be greater than negative 1. So this is the highlighted part which we need, and as we can see here, we have to calculate negative 3 to 0, and from that subtract negative 1 to 0, so to get our highlighted part here. So the probability for negative 3 and probability for negative 1 will be same as positive 3 and positive 1. So from the data here, we can get that point. 3 will be 4987 and 1 will be 3413. So we will just use that point here, and 4987 minus 3413, the probability will be 0.1574. So similar as of the last question. So from this we can understand that whether it is a positive or a negative value, the area is similar because our curve is a symmetric curve. So the distance of right hand and left hand side values are always similar. Moving on to the next question. Illustration 5. The monthly income of workers working in production house follows normal distribution. Their average monthly income is rupees 15,000 and the standard deviation is rupees 4,000. If a worker is selected at random, then find the probability that his monthly income is between rupees 10,000 and rupees 25,000. The percentage of workers having monthly income between rupees 12,000 and rupees 22,000. So let's start with the first one. The average here is 15,000, standard deviation is 4,000. We will be converting these values into Z. So first one, X has value between 10,000 and 25,000. So we convert this X into Z formula. First write down the probability value 10,000 less than equal to X less than equal to 25,000 and then converting it. 10,000 less than 15,000 minus 15,000 upon 4,000. 25,000 minus 15,000 upon 4,000. When you solve this, you get negative 1.25 less than equal to Z less than equal to 2.5. So draw a normal curve here and two values 1.25 and 2.5, and when you highlight the area you get something like this. So naturally first we will calculate area between negative 1.25 to 0 and then the area between 0 to 2.5, and that way we will get our answer. So negative 1.25 less than Z less than 0 plus P 0 less than Z less than 2.5. So we need two area 1.25 and 2.5. So from the table we can get these areas. First of all 1.25. So in this Z column we will find 1.2 and in this column 0.05. So 1.2 and 5, that will make it 1.25. So 1.2 value in 0.05 column, 1.2 value in 0.05 column is 3944. Similarly 2.5 is here and after that it is 0, so it in the 0 column. So 2.5 in 0 column is 4938. So we will add 1.253944 and 2.54938 values. So 3944 plus 4938 will get you the answer 0.8882. So this is the probability that the workers have their earnings. A worker selected has his monthly income between 10,000 and 25,000. This is the probability. Okay, so moving on to the second one of this question. X has value between 12,000 and 22,000, that is 12,000 less than equal to X less than equal to 22,000. So we will be converting this X into the Z column. 12,000 less than equal to X less than equal to 22,000. Do remember at the end we have to convert the probability into percentages because that's the actual question, but first we have to calculate the probability. 12,000 minus 15,000 upon 4,000 and 22,000 minus 15,000 upon 4,000 will make it negative 0.75 and 1.75. So from this value we can naturally draw a curve here. The values will be between negative 0.75 and 1.75. So the area we calculate is from negative 0.5 to 0 and 0 to 1.75. So from this table we have to calculate 0.75 and 1.75 values. So 0.75 will be 0.7 in the 0.5 column. So 0.7 in the 0.5 column is 2734 and 1.75 will make it 1.7 in this 0.5 column, which is 4599. So these are the two probabilities we are going to add to get 0.7333. Now our usual answer would have ended here, but we have been asked to calculate the percentages. So percentage of workers, that is simple, probability multiplied by 100. Any value you want to calculate a percentage of, because these probabilities are out of 1. Okay, so just multiply with 100 to get its percentages. So 0.7333 into 100 will make it 73.33 percentages. So we can say that 73.33 percentage of workers have monthly income between 12,000 and 22,000 rupees. So my reference, this is how you calculate the percentages. Multiply your probability with 100, that's all. That will be your answer for percentage. Till now the questions we have solved, the illustrations 1 to 5 were pretty simple minded. We had the values of the Z and from that we calculated the values using the table. Now we are going to learn a new topic in which we are going to use the table to find the values of Z. That means table values will be already given, and from that we will be calculating values of Z. It is known as checking the table or taking the table in an inverse order. Let's check out the illustrations based on this. Illustration 6, if the probability value of standard normal variable Z lies between 0 and Z1 and the probability is 0.3925, then obtain the possible values of Z score. That means the probability is already given and we need to calculate the possible values of Z1. Okay, so what we are going to do here, the probability value between 0 and Z1, where Z1 is not necessarily positive or negative because it can be either. Only the probability is given. We have not been given that Z1 is on the positive side of the curve or the negative side of the curve, because we know that the probability on both the sides is going to be same. So the probability between 0 and Z1, where Z1 can be positive or negative, is 3925. So we have two options here. The first option, we assume that Z1 is on the positive side of the curve. So if we know that it is on the positive side of the curve, we will know that the value of Z1, the probability of Z1 lies between 0 and Z1, which is 0.3925. So what we are going to do, we are going to take the table in the inverse order. Means right now we have the probability, so using the probability we will try to assume the value of Z1. So first of all we have to find the probability of 3925 from the given table. How we are going to do that? See, these are all the probabilities given in the table. I have not shown you the whole table here, but you will get the whole table and you will have to search from there. The given probability 3925 I can find in this part only, so I only copied it here. So see, all the probabilities are written here. So start with 3 value here. When you get the 3, okay, 3 is here. Then after 3 we need 9. So 3, 4, 3, 1, 3, 4, 3, 6, 3, 8 and then 4. So we don't need 4. So 3, 8. So we will now go horizontal here to calculate 3925. So 3925 probability we have got. So let's see what are the Z values for this 3925. The Z value here is 1.24. See, the 3925 lies in the Z value 1.24. So the Z value we can say here is 1.24, and because Z1 is on the positive side, this 1.24 will also be positive. But we also have another option where we are assuming that this Z1 lies on the negative side of the curve. So where we will write the probability as Z1 less than equal to Z less than equal to 0, which is 3925. We will take this table in the inverse order, and we already know that okay, 3925 has the Z value 1.24, but Z is on the negative side of the curve, so we will write it as a negative 1.24. So if we know that Z is on the positive side, we will take it as a positive value. If we know that Z is on the negative side, we will take it as a negative value, because our curve is a symmetric curve, our distribution is a symmetric distribution, so the distance on both the sides have the same area value. So either positive or negative, the area does not change. So it depends on where we write our Z. So right now the question was given that we have to write all the possible answers of Z. So Z1 can be either positive 1.24 or Z1 can be negative 1.24. Let's check out some more illustrations based on this concept. Illustration 7. If the probability value of standard normal variable Z are as under, then find the Z score. Now area to the left of Z is equal to Z1 is 0.95 and area to the right of Z, which is Z1, is 0.05. Now we have to start from the first question. Let us try to understand what they are trying to tell here. Area to the left of Z is 0.95. That means if we start from the left hand side of the curve, we move towards the right hand side up to 0.95 value. Now we need to remember here that the whole curve has the value 1. and the left hand side and the right hand side parts of the curve has the value 0.5, 0.5. Right now our probability value is 0.95, which is on the left hand side of the Z1. So we start from the left hand side and we go up to go towards the right hand side up to the value 0.95 is achieved. How we are going to write this? Because it is on the left hand side means less than, so z is less than z1, which is 0.95. Now if I draw the curve here, it will become easier to understand. So the curve here will look like this, where I am going to start highlighting my area starting from the left hand side, and I will go up to I get my probability 0.95. And remember the whole value is 1, so naturally 0.95, if I start from here, it is going to cover most area of the curve. So starting from negative infinity, my area will end somewhere here, keeping a small gap blank. So when I draw a line here, that I will call Z1. So Z is less than Z1, the probability is 0.95. So whenever we have a left hand side or the less than type, always start from the negative infinity value, because left hand side or less than values are from negative infinity. So now if I split up, if I draw my equation here, or I split these values, I will get from negative infinity to 0, and I will add 0 to z1 in there, which is 0.95. Now we all know that the negative infinity value has 0.5 value, so 0.5 plus 0 to z1, which is equal to 0.95. I will just change the side of 0.95 to subtract it from 0.95. I will get 0.45. So now I have to take my table in the inverse order to calculate the probability 0.45, and the z value for that 0.45 will be the value of z1, and we know that z1 is on the positive hand side, so our answer will should also be positive. Now I am taking the table here 0.45. So let's start with calculating 0.4. I am talking here. So this is zero point 0.4. After 4 I need 5. So 40, 41, 43, 44, 45. But I don't need this big value than 4, 5. I just need 4, 5. So I may have to go back a bit and see here, these are the two values. This is 4495, which is less than 0.45, and this is 4505, which is more than 0.45. So you see, we have to take some values which are closest to our answer. My answer is 0.45 and I need to get the closest value, so I have got two values here. So the z value 0.4495 is 1.64, and it is 4505 1.65. So I can take either of them because they are not the exact values, but my value lies somewhere between. So I am going to take an average of 1.64 and 1.65 z values. So my z1 will be the average between 1.64 and 1.65 values, which will be 1.645. So the z1 in this case, the z score value in this case will be 1.645. So whenever we don't have an exact value, we take an average of the two closest values to our answer, to our probability, and that z score value will be our answer. So z1 is 1.645. Let's solve the second one of this, so we can still get the better idea out of this. The area to the right of z is 0.05. That means if we start from the right hand side of our curve, we move towards the left hand side and up to only 0.05, and our whole curve is 1. Now we have to remember that the whole curve is 1, so on the right side part will be 0.5, the half value, while what we need is a very tiny bit value, which is 0.05. So right hand side of the curve means whatever is the z1, we are getting a bigger value than that. Right hand side of any number line is the bigger value, left hand side is the smaller value. We are going towards the right hand side, so we are going towards a bigger value. So z1 is less than z, that is z is greater than z1. So if I draw a curve here, I will get something like this. I am only going to highlight this small part. Okay, I am going to start with my positive infinity value, because right hand side means the positive infinity. I am going towards the right hand side, so from right I will start towards the left uh, direction, and I only have a very small value of probability, that is 0.05. So this is the only part which I am going to highlight here, and thus the z1 value I get. So looking at the curve, we know that we are calculating probability between z1 and positive infinity. So it will be split up as 0 to infinity minus 0 to z1, that is 0.05. Now we know that infinity value is 0.5, so we will put that in the place of infinity. Now we are going to swap the positions of z1 with 0.05. So it will be 0.5 minus 0.05, and thus the z1 value here will be 0.45. Now we have already calculated the table value for the probability, the standard score, z score value, but let's see it again. So we need 4 5. We will check out the 4 first, then 5, the nearest two values of 45, 4495, 4505. So 1.64, 1.65 are the two values, the closest values from our z score. We will take an average, and we will get our answer of z1 is 1.645. So whenever the question is asked in a manner of right hand side or left hand side, you start your probability from that side and you go in the opposite direction up to your probability is that, and accordingly you draw a line, a vertical line showing your z score value, and then put it into our split up values or equations, and then simplify it, and then take it in the table, find that probability in the table, and find the z value from the table. And if it is not there, exact value is not there, take two nearest values, one greater, one smaller, and take an average of them. You will get your z score. Let's take a last illustration based on this concept. Illustration 8. If the probability value of standard normal variable z are ascendant, then find the z score. First, area to the left of z is 0.10 and area to the right of z is 0.90. So we have something similar like the last question. Area to the left of z is 0.10, and that means that if we start from the left hand side of the curve, we move towards the right hand side of the curve up to 0.10 probability. Let me remind again, the whole curve is 1 and we are only checking out 0.1. Okay, only the 10% part of the curve is what we are checking out, because it is on the left hand side. Left hand side is always less than, so z is less than z1, which is 0.10. Now let's just draw the curve here so that we can get an idea. Now we are starting from the negative infinity side because that's the left side, and we just go up to 0.10. Now this is again a very small probability, so it will be z1 and it will be on the same side. Now this time z1 is on the negative side or the negative part of the normal curve, so whatever answer we get for z1 will be written in negative values. Now we will split it up according to our highlighted part, which is from negative infinity to 0 minus z1 to 0. So this whole value minus this blank value will get us this highlighted value. Now we know that infinity is 0.5. We will swap the sides of 0.10. So the probability which we are aiming for, z1 to 0 probability, is 0.4. So when we check this out in our table, we will know the answer of z1. So taking table in the inverse order. Now this is your table. We need to find the value of 0.4. So we will start here, 2 2 2 3 3 3 3 4, but this is 4032, which is greater than 0.4. So let's move it back a little. This is 0.4015 and 3997. So you can see that this value is less than 4 and this value is more than 4. Exact 4 is not available, so we will take an average of these two values. Now the z value for 3997 is 1.28 and Z value for 4015 is 1.29. So let's take an average of negative 1.28 and negative 1.29. Now, why I am taking it as negative? Because from the curve we know that Z1 is on the negative side. So both values we have to take as negatives, and when you take an average you get negative 1.285. So negative 1.285 is the z-score value for the given probability. So we can say that if z1 is negative 1.285, then the area to the left of z1, area to the left of negative 1.285 will be 0.10. Okay, so z1 is negative 1.285. Let's take the second question for this. Area to the right of z is 0.90. That means if we start from right hand side of the curve, we move towards the left hand side up to only 0.90. The whole curve is 1. Okay, so I am just reminding you guys. So right now z is greater than z1 because we are going towards the right hand side. Okay, so z is greater. Whenever we are going towards right hand side, it is greater value. Left hand side is the lesser, smaller value. Right hand side is the greater value. So we will start calculating our probability from the right hand side of the curve this time. So it will be highlighted for 0.90 probability. Remember that thing, it is 0.90. Okay, so just this whole part is 0.5, so it is still greater than that because we are still moving forward up to this point, and that would be your z1 value. Now remember guys, while drawing this curve you just have to take an estimated highlighted area. Okay, so that means if it is 0.90, you just have to take any point somewhere here. It is not going to be a pinpoint accurate point. We don't know, we don't actually calculate these areas directly, right? So just take an estimated point somewhere here. Okay, if it is 0.5, then it is whole this part, something like this. Take estimated values. You don't need that much to pinpoint the highlighted part of the area, but it should give us a general idea. So right now we know that it is from z1 to positive infinity. So we will take our probability as z1 to 0 and then 0 to infinity, which is 0.90. Now infinity is 0.5, so it is z1 to 0 plus 0.5 is equal to 0.90. Simplifying it, 0.90 minus 0.5 will be 0.4. And we already know from taking the inverse table that 0.4 lies between 3997 and 4015. So it is 1.28 and 1.29, and z1 is on the left hand side, negative side, so it will be negative 1.28 and negative 1.29. We have to take an average of these two values, which will be negative 1.285. So once again, we have got something similar because the questions have been asked in such a manner that we get the same answer does not mean that you will always get the same answer. So trust in your equations, trust in your table. Okay, don't just what we can say, put the values out of thin air. Calculate them properly. I hope you guys understood the concept of taking the table in inverse order through 3 illustrations which I explained in this tutorial. In my future tutorials, I will keep on explaining further illustrations because this chapter does not have a proper exercise. It only has a final exercise. So I will explain this whole chapter through illustrations only. I hope you like this. If any comments or questions, you can put it in the below comment box, and I will see you next time. Thank you. Welcome students to With Answers Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.